Hi guys, this is Vineet, and in this video we will discuss about using the dynamic SQL inside the SQL Server Stored Procedure. Uh, so what do we mean by term dynamic SQL? So basically dynamic SQL means that the SQL or the T-SQL script generated on the fly during the stored procedure executions. On the flight means that the dynamic SQL is generated or the SQL script is generating during the runtime of stored procedure. So let's see. Let's look into the formal definition of dynamic SQL. So dynamic SQL refers to building a batch of SQL code. I was referring to a script. So it refers to building a batch of SQL code as a character string, and we usually store this string inside a temporary variable, which is stored usually in a variable or a temporary variable, and we then tell SQL Server to execute the code that we stored in that particular temporary variable or a variable. So below is the paragraph discussing about some limitations of using the static queries which are not dynamic. So using static queries is not good for query performance, as SQL Server caches the query plan, incorporating all the possible filter predicates. So why static queries are not good? These are not good for query performance of SQL Server because while executing the static query, the SQL Server caches the query plan of that query. So let me show you first what is a query plan. So let me take you to the SQL Server environment. Here we are inside the Northwind database. So if I execute a new query and I'm using orders table, so let's say I issue a select statement, select top 100 from orders. Okay, and I execute this statement. So the right query is select top 100 star from orders. Let's execute this, and I got the output, but this is not a query plan. This is generally simply the output of this running this above query. So let me show you what is the query plan. So if I select this query, and there is a button over the top, so you see display estimated execution plan, the button which is right next to the pass button. You click on this, it calculates the query plan and it show you graphics like this. So here the maximum cost is while executing this query, the maximum cost get involved in going through a index scan, which is a cluster index. So majority of time taken by query is during this process, during the scan of the index, which is defined on the orders table, and the index is primary key orders. So this is a cluster index, and that index gets scanned before a query fetches the output for us. Alright, so this is the plan, basically what we were referring to. So while using the static query, it is not good for query performance, and because the SQL Server caches the query plan. We were talking about the query plan where I had shown you the graphic. Alright, so SQL Server caches the query plan, and which incorporates all the possible filter predicates, and not just the one related to parameters. So basically whenever the SQL Server caches the static query plan, it incorporates all the possible filters that we use in the query, and not just the one for which we are passing the parameter value, that are applicable in the execution that gets optimized. So SQL Server optimizes query with or query plan with all the possible filter predicates, and not just the one which we are passing to the stored procedure, or whatever parameters are applicable in the query. Only those do not get optimized, but all the parameters do get optimized. So why SQL Server does this? So why it optimize all the parameter instead of just the ones getting used inside the T-SQL query. It does so because if SQL Server just caches the plan with parameters applicable in the execution, okay, so if SQL Server just caches only those parameters which are applicable in the current instance of execution, then it cannot use a plan where query gets executed with different set of parameters. So the issue is that if SQL Server just caches the plan with certain set of parameters, it cannot reuse those plans for a different set of parameters. That's why it makes a generalized plans which includes all the parameters and use that plan for all the future invocations of SQL query. So this results in caching of a general plan which I was talking about. That is not optimal for all the possible combination of parameters. Alright, and so basically what is the way to get an optimized plan for every possible combination of parameters? So for that we need to use the option Recompile Option. So basically if we need a plan which is good or optimized for all the possible combination of parameters, we use the Recompile Option. So we use this syntax, query option recompile. This is the exact code. So let's discuss about one of the sample codes. So the table we have used is the order info table. So we can find this table inside this Northwind database. So orders, I do not see order info table. There is the order details table. So yeah, we can equate order info with the order details table. Same thing. Alright, so let's look at the stored procedure. So where we are so this is not we are talking about stored procedure and we started looking into the tables. So yeah, stored procedure is different and we can find stored procedure inside the programmability section, and if we go inside stored procedure and we can expand on that. So here we have order info stored procedure already created by us earlier. We can drop this stored procedure and create a new one. So let's look into this. So here's the code for building our order info stored procedure. So we generally start with the statement create or alter a stored procedure, and this is schema name, this is a stored procedure name, and we are defining 4 temporary variables. First one is order ID, second one is order date, third one is customer ID, fourth one is employee ID. Order ID is integer type, order date is date type, customer ID is varchar 50 type. It can contain correctives, and the employee ID is integer type. And we are taking the default value of these parameters as null. If nothing is passed, these parameters will be set to null by default. So this is the syntax for creating a stored procedure. So here we have defined the header of the stored procedure. Now we are defining the body of the stored procedure. So we start with keyword as, and we are turning 2 of the options on. So first we are setting exact abort to on and setting the no count to on. We had discussed about these properties in our earlier video. So basically exact abort basically aborts if the SQL code is aborted and then in certain conditions transaction do remain open. With this setting turn to on, exact abort set to on, if there is an error raised during the execution of T-SQL code, basically it stops the execution of code and it cancel out or rollbacks all the transactions that are open. It does not leave any open transaction at that point while we are using the or when this option is set to on. The second option is no count on, refers to when we execute a query, it generally gives the messages like how many rows are affected. Basically if we set a no count to on, it generally omits that messages from the output in the messages window of SQL Server. So here is the body of the SQL Server. Here we have used option recompile option, which basically generates the customized optimized plan for using when we use certain set of parameters. So here's the body. We are selecting certain fields: order ID, order date, ship date, customer ID, employee ID, ship wire from the orders table, and here we are specifying the condition where order ID equal to whatever value is passed to the stored procedure in the order ID variable, or order ID is null. So here we are evaluating a where condition. So either we have passed the order ID value, or even if the order ID is null or no value is passed, this condition remains true. Okay, so for first condition remains true even the value is passed or even if the value is not passed. Second thing is there is an AND clause, so there is another test for another condition. Order date can either be order date or order date can be null. So under all the circumstances, these four conditions come out to true, whether the value is passed or whether the value is not passed. Null will be taken. When the null will be taken, the value of this particular predicate should be true. Alright, and in the last we have specified the option recompile option, which contains the customized optimized query plan, even if we use only certain set of parameters. Now when we use the above option along with the query in the stored procedure, SQL Server optimize every query from scratch. So if we use this option recompile option, SQL Server optimize every query from scratch, and it replaces every parameter with constants and normalize the query to remove redundant parts. Here we are taking an example. For example, if we execute a stored procedure providing only input to this parameter, order ID parameter, example we have passed 10249, the query which get optimized is as below. So if we have just passed the value for one parameter and not for other parameters will be null in this query. So the resultant query which get optimized is given below. So it takes the query as this is the query, alright, and where order ID equal to 10249, it optimizes only this part and not for each and every other part. Just optimize this query for one particular parameter, order ID. The likelihood, let me check one second. So the likelihood to get efficient plan with the above solution is quite high. So if we implement the above solution with option recompile option, even if we pass value for any of the parameters and omit passing the values to certain parameters, it creates a specific plans which get ultimately optimized for only those set of parameters. So the likelihood to get an efficient plan with the above solution is quite high. However, it comes at a cost of recompiling the query at every execution of stored procedure. No doubt the above option, or if we write stored procedures with this option recompile option, it gives us the optimized plan for every situation or every set of parameters, but it comes as at a cost, and the cost is recompilation of query at every execution of the stored procedure. So this is the part. Let me make it bold, one sec. This is the main point, so I'm highlighting this. So no doubt we will get the efficient plan for every combination of parameters with the above solution is quite high. However, there is a cost involved, which includes recompilation of query at every execution of the stored procedure. So basically, what if we want the benefit of both the things? We want the benefit of optimal plans that we have seen above and cache query plans. What if we want benefit of both these situations? First one is this: we get the optimal plan for specific set of parameters. Second is that we also get a generalized cache plan as well. Then we need to dynamically build the query string. So the solution is to build, not use a static query like this given in the stored procedure. This is a static query, and the code is not generated on the fly. We have specified the code or specified the static query while building the stored procedure. So the other solution is to use a dynamically building the query string with only the relevant parameterized predicates. So basically, the way of getting benefit of both the optimal plans and the cache query plan is to use the dynamic SQL or dynamic building a SQL query string with only the parameters that we require, and execute the resultant query code, which is a dynamic query code, with sp execute SQL stored procedure. This is the stored procedure we will use to execute that code. The dynamically generated code can be executed through this stored procedure. So let me show you the approach. So below is the code which is showing the implementation of this approach. So again, the same stored procedure, create or alter procedure, tb order info, same 4 set of parameters: order id, order date, customer id, employee id, integer date, varchar 50, and integer type. Default values are null. Exact abort and no count options are set on. Here now in the body of the stored procedure code, we have a different code. So here we are declaring a temporary variable which is SQL, and we are specifying it as an varchar max type. It can take a maximum number of characters applicable for an varchar type, and here we are specifying n for holding the Unicode query string, because this is a Unicode data storage type, and stands for Unicode. So if we are using this parameter, we need to specify the string literals with n parameters, starting with n parameter. So here's the actual query string. Select order id, order date, ship date, customer id, employee id, ship via from orders, where 1 equal to 1. So by default this condition is true, right? So the first condition we have taken is true. So basically, if we just execute this query, it will fetch out all these particular columns from the orders table. Okay, so we understood this statement, right? And in addition to this string literal, we are combining some additional string literals. So here we are defining cases on the case-by-case basis, which parameters to pick up, which parameters not to pick up. So the first statement is case when order ID is not null. Then so here we are formally determining whether the parameter is passed, the value is passed for the order ID parameter. So here we are checking this, checking for the case when order ID is not null, when the value is passed. Then we take this string literal and order ID equal to order ID. We combine this string literal with the above query if value is passed, else we don't add anything. So this is a null string literal, we are not adding anything to this particular query. Okay, and we are ending this case. And similarly, we are taking cases for the other 4 parameters: the order date, customer ID, employee ID. When the values pass, we take the AND condition and the value of that particular variable for the order date column, else we are taking empty string literals. So in the end, we are just adding that statement terminator for the select statement we are building up. And now in this part we have built our dynamic query, right? So in order to execute the dynamic query within the stored procedure, we need to specify the execute, and we need to execute the sp execute SQL stored procedure, which is a system stored procedure, which is an inbuilt stored procedure inside SQL Server, and this is the schema for that particular stored procedure. So we execute the stored procedure like this, and we need to pass parameters to this stored procedure. So we pass statement parameter, and statement is the SQL statement we have generated, which is inside this parameter string literal, the SQL string literal we have generated. and we pass it to the statement parameter for this stored procedure, and we specify the params clause to specify what parameters do we have for this stored procedure. So here we are specifying the Unicode string literal as order ID as integer, the same thing we have specified above. You need to specify that. So order ID is date, customer ID as varchar 50, employee ID as integer type. So here we are specifying all the parameters that we are using inside the Dynamic SQL. These has to be declared to the params temporary variable for this particular stored procedure. We need to specify all the 4 parameters. So this is basically the declaration of dynamic batch parameters. We declare a corresponding dynamic batch parameter for each of the stored procedures parameters. So stored procedure parameters are this, and we create a corresponding dynamic batch parameters. So these are dynamic batch parameters. These 4 are dynamic batch parameters, and we pass the value of the stored procedure parameters to the dynamic batch parameters. So this is the assignment of stored procedure parameter to dynamic batch parameter. We do it for all the 4 parameters defined for the stored procedure. And in the last we provide statement go. So this is our complete stored procedure that we have to execute, and we use the below code to test the stored procedure. So let's test it for order ID 10249. So first of all, let me go ahead and create this stored procedure quickly. So I'm copying out this code. I would suggest you to write this particular code, the whole set of code, manually, so that you get better grasp on T-SQL. So for now I'm just going ahead inside SQL Server, I'm pasting this code and I'm executing this code. So this code is executed. Now what I have to do is execute this stored procedures order info. So we need to execute by using the exec statement, then the name of the stored procedure, which is dbo.orderinfo, and next we have to specify the order ID parameter value. Order ID I'm specifying whatever is mentioned in our notebook, 10249. Let's see what parameter do we get. So in this case we have built a stored procedure which will optimize the query plan as per just the order ID parameters, because in this invocation we are just using a single parameter and not all the 3 parameters. Other 3 parameters we are not taking any value for that. So a dynamic SQL is generated. Here only just a SQL is generated equal to, let me show you what SQL is generated. It generates this SQL, not the other parameters. It will just take the order ID parameter, not the other parameters. Alright, so let me go back and execute this. So it has given me this particular info, the order details for order ID 10249. So guys, we have just shown you the implementation of Dynamic SQL using Dynamic SQL inside the stored procedure. So what's the benefit of using this Dynamic SQL? It results in giving us the optimal query plan. So each unique query string use different combination of parameters which get optimized separately. For same combination of parameters used next time in a query, a previously cached plan is used. So for example, if we just change the value of this parameter to 10250, so during our previous invocation, one of the query plan got cached for the order ID parameter. So next time that cache plan will get used if I use the same set of parameter. Here in the next query we are just using order ID, so the cache query plan will get used. Alright, so that's the benefit. Okay, so I think we are done with this particular video using dynamic SQL queries inside the stored procedures. Um, Thank you for watching my video. Do like my videos and subscribe to my channel. And if you need some SQL videos on any other topics, please comment on this video, and I will try to make that particular video with that particular topic you are interested in. So guys, thank you once again. Have a nice day.